Okay, so today we're going to be going over the properties of trig functions. And I want you to remember we studied a vocabulary word that was coterminal. And coterminal means they have the same terminal side. That means they end in the same place. Just very quickly, an example, we had the 45-degree angle, which was in quadrant 1. And remember the rotation of 405-degree angle, where we went around to the same location. And it was coterminal because the only difference was the amount of rotation that we had, but the end side, the coterminal side, was at the 45-degree mark in quadrant 1. Well, if they ask us for a coterminal for an angle that's not on the unit circle, we have to remember first that one circle is 360 degrees. And so if I have an angle that's outside of that normal 0 to 360, to find a coterminal that's in the unit circle, we would either add 360 degrees or subtract 360 degrees from 650 degrees. So if I take 650 degrees and I subtract 360 degrees, I get 290 degrees. Now, 290 degrees may not be a value we knew on our unit circle, but it is in the normal circle between 0 and 360, and therefore 290 degrees is a good answer. It is coterminal with 650 degrees, and it's between 0 and 360. Okay, it's between 0 and 360. So let's take a look at this next problem that says give 5 angles that are coterminal with 30. Now these are not the angles that necessarily have a reference angle of 30 degrees. We had several of those, but these are ones that are coterminal, meaning they end in the same location exactly as the 30-degree angle. So I can start with 30 degrees. That's one angle that ends at 30 degrees. If I take 30 degrees and add 360, I will get 390 degrees. That is another coterminal angle. Now it's a different angle. If you had to travel around the circle as a 30 degree or 390 degrees, you'd be turning a different amount, but you'd be facing the same direction in every case. You would have your final terminal side would be right there at 30 degrees. Well, let's take 390 degrees and add 360 again. And we're going to get 750 degrees. A 750 degree rotation would be coterminal with 390, because if you rotate it around two full times and a little bit, 30 more degrees, you would still be facing the same direction. Well, let's take the 30 degrees and subtract 360 degrees. That's going to be negative 330 degrees. Now remember, negative 330 degrees is a rotation in the other direction. It's a rotation clockwise. And if I rotated 330 degrees clockwise, not quite the full circle, we would be terminating on this still side, on this terminal side. So that's another coterminal. And finally, let's take 330 degrees, subtract 360, it was negative 330, my bad, negative 330, subtract 360 again, and that's negative 690 degrees. We now have 5 coterminal angles, all of which, depending on the rotation to clockwise or counterclockwise, would end up at the same terminal side. So with degrees, one circle is 360 degrees, and that's pretty straightforward. But what if we had radians? What if our circle notation angle was in radians? Well, now I have to remember that one circle is equal to 2 pi radians. One circle is 2 pi radians. That's a different measure. So we're not going to be adding or subtracting. We know 17 pi over 4 is not in our unit circle, and they want an angle on the unit circle. So 17 pi over 4 is not, but we're not going to subtract 360 degrees. Instead, we're going to subtract 2 pi. Now you know we have a fraction here, minus a whole number, so we've got to make that a fraction. And we cannot subtract fractions that don't have a common denominator, so let me get a common denominator of 4. And how do we do that? We multiply the top and the bottom by the same thing. And that's going to give me 17 pi over 4 minus 8 pi over 4. Now I can subtract 17 minus 8. 17 pi over 4 minus 8 pi over 4 is 9 pi over 4. Well, that's still not on the unit circle. So let's subtract another 2 pi, which is subtracting another 8 pi over 4. And this is coterminal with pi over 4. Imagine if I was going around the circle, I would go one full circle was 8 pi, 2 full circles was 16 pi over 4. Therefore, there's 1 left. 1 pi over 4 is coterminal with 17 pi over 4. Okay? With 5 pi, we'll subtract 2 pi. That equals 3 pi, still not on the unit circle. Let's take 3 pi and subtract 2 pi again, and we get pi. Pi is on the unit circle. That is coterminal, meaning it ends in the same location. So if I'm not sure where 5 pi is, think about where pi is. We went around the circle 2 full times. So in other words, if I was drawing this picture, it'd be around the circle once, twice, and then back to the pi location. That's where 5 pi is located. 15 pi over 4 is not on the unit circle, so let's subtract our 2 pi. Can't do it. Denominators aren't the same, so let's make a common denominator, and we will get 15 pi over 4 minus 8 pi over 4, which is 7 pi over 4. That's on the unit circle, and so we can stop because we know where 15 pi over 4 would end. It would end in quadrant 4 over here at the same location as 7 pi over 4. Now, why would we want to know how to do this? Well, if I wanted to find the cosine of negative 60 degrees, and I can't figure out where that is or how to find it, by finding a coterminal, taking negative 60 plus 360, we're back in degrees again, so plus 360, means that's the same value as the cosine of 300 degrees. Now I know cosine of 300 degrees is in quadrant 4. In quadrant 4, cosine is positive. This is a 60-degree reference angle, and therefore it's going to be positive 1/2. The cosine of negative 60 degrees is positive 1/2. Now that's just another way of finding it. You could have found it many different other ways, using the unit circle where I showed you to go to 60 degrees, it drops straight down. You could use it by using reference angles of 60 degrees and knowing that it ended up in quadrant 4 anyway, where cosine was positive. This is just one more way that we can find the cosine value using another method. Negative 390 degrees is not in the unit circle, so I'm going to add 360, and I'm going to get negative 30. Negative 30 still isn't the unit circle, so I will add 360, and I get 330 degrees. I want the sine of 330 degrees. You could now go and look at your unit circle or look at your reference angle table and recognize that sine is in quadrant 4 is negative. That's going to be negative 1/2. Last but not least, we have this one over here. Remember, this one is not in degrees, so we're not going to add 360. We're going to add 2 pi. And you're going to have to do that several times. We're going to have to add several versions of 2 pi and know that it is equal to 7 pi over 4. So the tangent of 7 pi over 4, negative 1. I'm sorry, 3 pi over 4. 3 pi over 4. The tangent of 3 pi over 4 is -1.